Welcome everyone. In this video, we want to consider an interesting property of refraction. Let's say that we have three surfaces, three of them. One and two lines. This one will be the surface one, this one will be the second one, and this one will be the third one. We have not surfaces actually, we have three mediums. Okay, these are three-dimensional. Now, there will be a light that is coming through, perhaps like this, and it will be refracted. That is, its direction of motion will change. Perhaps it goes, I don't know, like this, and then it will be refracted again as it changes medium. Let's say it is like this. Now, whenever we are dealing with refraction, we want to draw the normal lines, because the angle that the light beam makes with the normal is very important for us. The normal line will be at the point of contact, and for this one as well. These are normal, that is, these are 90 degrees. Cool. And we have this case. Now, I'm asking, I give this angle as alpha. Okay? That angle is alpha, the incident angle, the angle that the incoming ray makes with the normal line is alpha. And I also tell you that if I were to have medium 1 and medium 3, and if I were to send a light beam with the same incident angle, so if I draw the normal line like this is the normal line, these were normals as well, and this angle is again alpha, the light will be refracted perhaps like this, and this angle is beta. My question to you is, what is this angle? What is it? I want to give you a couple of seconds to pause the video and think of it, and when you're ready, continue it. Alright, I assume you gave it a go, you tried to do it, and now you're back with me. So, how to tackle this problem? We want to first focus on Snell's formula. And for Snell's formula, we will need to first write the refractive indexes of each medium. So this will have N1, N2, N3, N1, and N3. And how was the refractive index defined? Well, N, the refractive index, is defined to be the speed of light in space divided by its speed in the medium. And as you can see from this definition, N is going to be less than or equal to, N will be greater than or equal to 1, because V can't be greater than speed of light in the space, okay? Because at that point there is no resistance, there is no air, nothing. So it is fastest in the space. That's why V can't be greater than C, so N will be greater than or equal to 1. This is the definition of refractive index. Now, using this, we want to benefit from Snell's formula. What is Snell's formula? Snell's formula tells us if there is refraction, then N1 times sine of theta 1 equals N2 times sine of theta 2. Cool? And what is theta? Well, theta is the angle that the light makes with the normal. So, and by the way, I proved this in a previous video. You can access that video from the cards right now and also from the descriptions part. Now, you might be asking, how does this help us? This helps us because, look at this. So in this two medium case, we will have N1 times sine of alpha equals N3 times sine of beta. I just applied Snell's formula. So we have this relation. Now I want to focus on the initial picture, this one. I will first consider the first refraction, this surface. And by the way, I should have said this, or perhaps did I say it? I don't know. But if I didn't say it, this and this are parallel. The two transitions between mediums, they are parallel, okay? This is correct. What you're about to prove is correct for parallel refractive surfaces, and you will understand why it is correct for parallel ones. So from the transition between 1 and 2, we will have n1 sine of alpha equals n2 sine of, well, we need to define an angle. That angle will be this one. We perhaps call it theta. So it is sine of, let me switch back to orange. Which one was it? Was it this one? Yep. So sine of theta. So this came from the first transition, from medium 1 to medium 2. This is the first refraction. Now comes the second refraction. Second refraction is from n2, we will have sine of, we need to name this one as well. What should we name it? We should name it theta, because it is the same angle. This is where the parallel part comes into play. If you have two parallel lines like this, and you have a, let's say it's like this, you have an intersection, not an intersection, you have a line like that, and then if you think of it, this angle and this angle, they are both theta, they are equal. So this is why it was important for us to mention that these are parallel. Alright, so I'm using that to say theta here is equal to n3 sine of this guy, which we can call question mark. So we have sine of question mark. Well, look at this. N2 sine theta appears in both equations, which means we can substitute this here. N3 sine of question mark. And when we do that, surprise, surprise, we see n1 sine of alpha equals n3 sine of question mark. But we also had this. This means since n3 is constant, sine of question mark should equal sine of beta. That is, question mark was beta. The angle of refraction was beta. The angle that the exiting light made with the normal was beta. So in fact, it doesn't matter if we have 2 between 1 and 3, because the result is the same. And in fact, if you had 2 and other mediums between 1 and 3, you still would get the same result. An important mention here is to consider this statement more mathematically. That is, if sine of question mark is equal to sine of beta, question mark is equal to beta. We already said that. But it is also equal to, so question mark is also equal to, what was it? It is 180 degrees minus beta. Okay? It can also be equal to 180 degrees and beta. However, this doesn't make physical sense in the way we drew it. For example, let me draw it here. If this is, if beta was 40 degrees, okay? If beta was 40, then what would you do here, right? It would be kind of not refracted, but it would be reflected. That's why we don't consider the case where question mark is equal 180 degrees minus beta. Okay, I hope this makes sense. And if it doesn't, and if anyone have a better way of explaining it, please write your way in the comment section. But I hope that this solution makes sense. Anyway, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.